Hi, Miss Marion here. Let's go ahead and let's do lesson 12 of unit 2. Go back and turn to page 124. And let's go ahead and read our I can statement. I can find an equation for a line, that is line, and use that to decide which points are on that line. Okay? And so go ahead and give yourself a sentence about how you feel about that, and then a number 1 through 4. 1, I don't know what you're talking about. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So give your sentence and a number. All right, let's go ahead and turn to page 105. And let's go ahead and do the missing center. So a dilation with scale factor 2 sends A to B, where the center, where is the center of dilation? So go ahead and pause for a second, answer that question. You're going to draw it on your piece of paper on your workbook on page 105. Now that you have had time to go ahead and find your center point of dilation, let's go ahead and walk through that. And so what we're going to do, easiest way to do it is, let's go ahead and draw a line between A and B, and I'm going to draw it even further. Because remember, the center point of dilation is going to, and especially if it's 2, it's going to take that A and kind of push it away from the center point. So that means my center point is going to be down here somewhere. Well, how do I find that? What I'm going to do is I'm going to measure between A and B. So you can either do it with a ruler, you can kind of put that amount of distance on like a card or a sticky note or something like that. And then remember, it's a scale factor of 2. So right here, what we have right now is 1, and I need another kind of that set to make 2. So if I measure it, it's going to end up being somewhere down here as far as where that center, so this is my center of dilation. And if you did not get that, you can go ahead and fix that on page 105. All right, let's go ahead and turn to page 106. On page 106, we have this activity, the 12.2, writing relationships from 2 points. And so we have this diagram. And we have number 1, use what you know about similar triangles, find an equation for the line, and let's go ahead and just stop there. Let's go ahead and make sure that our equation is correct. So go ahead and pause, go ahead and find your equation. Now that you found your equation, let's go ahead and see if we have the same kind of thing. So remember, we are doing similar triangles. We are putting similar triangles on a line, so kind of like how lesson 11, we're just kind of adding more to it here. And so we can actually make different triangles. And also we kind of remember the pattern that we go ahead and use for it. So what I'm going to do is I'm going to look at this triangle here. And again, I need so really what we're doing, remember our slope is our vertical over horizontal. And remember that that was one of the triangles from lesson 11. And so I'm going to find, on this blue triangle, I'm going to find my vertical. And then I'm going to find my horizontal. So my vertical is 1, 2, 3, 4. Or if I look at it, the vertical is the X stuff. So if I do 7 minus 3, so I'm going to actually write that down. So we go 7 minus 3, we get that 4. And then also, now I need to find my horizontal. We can count it, it's 2. But we can also do it as we have, if we look at the X values, it's 7 minus 5. Those are the X values or the horizontal. So 7 minus 5, which is 2. So my slope for my blue triangle, or my vertical over my horizontal, is going to be 4 divided by 2, which can reduce down to 2 over 1, or just 2. I'm going to go ahead and erase my blue triangle because we're going to be drawing some other stuff on there. Now let's go ahead and let's make a second triangle. So remember we had two triangles during lesson 11. And I'm going to make this triangle up here. So remember, we do have 2 points. One is 7, 7. The other one is x minus y. And so we kind of follow the same pattern as far as trying to find the vertical and trying to find the horizontal. So remember, during lesson 11, what we did is we y minus 7 for the vertical. So remember, it's the y stuff, so we have y minus 7, so that's the up and down, right? And then we're going to do the x part, and we have x minus 7. And again, that's the x. We have x minus 7. And this was the second triangle that we did on a lesson 11. And then we actually made it equal to each other. So we said that we had our slope, which is 2 over 1, and we made that equal to the other triangle, which is y minus 7 over x minus 7. So this is one equation that we could have made. We also could have made a different one. So I'm going to erase this red triangle because again I'm going to draw on it. The second triangle that we could have drawn is this bigger green one. So again, if we look at the two different points, I have 5, 3, and I have x, y. So again, I want to find my vertical. That's my y stuff. So again, if we follow the same pattern as far as in lesson 11, we did y minus 3. And then for our horizontal, that's the x stuff, we did x minus 5. So again, we had it as the y minus 3, x minus 5. And so these are the vertical and horizontal of the green triangle. And so we can find that slope. We can do the vertical over the horizontal, which is, so vertical is y minus 3, horizontal x minus 5 of the green triangle. And then we can also still, if we were thinking back to that blue one where we had that number, it was 2 over 1. So this is a second equation that we could have had. So we could have had this one up here or this one down here. Now you're like, oh, but Miss Marion, there's two equations. Is this going to work? Yes, this will actually work. Both of them work no matter which one we use. We'll still get the same equation. We won't have the same equation, but we'll get the same answers if we're trying to figure out different things. So on number 2, what is the slope of the line? Remember, we actually did that. Our slope of the line is 2 over 1 or just 2. So see how that's part of both equations, and we can actually go ahead and use it. Then let's go ahead and let's look at 9, 11. Is this on the line? So we're actually going to go ahead and we're going to use, we can actually use either equation. We'll actually get the same thing. Let's go ahead and let's do this top one first. And we'll actually try the second one also. So we're going to go ahead and put that 9, 11. We're going to go ahead and put it into this equation first. So let's go ahead and let's do that. So the y is the 11. So we're going to say 11 minus 7 over, and then the x is the 9. We're going to go 9 minus 7. And let's go ahead and let's find that out. So grab your calculator. 11 minus 7. That is 4. 9 minus 7, that is 2. Reduce that down. Does that equal? That equals 2. So does that equal our slope that we found out before? Well, 2 over 1 is the same as 2. So is 9, 11 on this line? Yeah, it is. So let's try our second equation. Let's see if that one works too. Same thing. We're going to put our y minus 3. So we're going to do 11 minus 3 because we're putting it up in this equation up here, right? And then it's going to be over 9 minus 5. So let's do 11 minus 3, and that equals 8. 9 minus 5, that equals 4. and 8 divided by 4 is 2. So see, notice how either equation, because yeah, 2 is our slope, and yeah, so this is, so our answer over here is yes. But notice how either equation works. We used this one and this one, and both of them showed that that point is actually on that line. So let's go ahead and let's answer number 4 is 100, 193 on the line. I'm going to do that work over here. And again, as we showed, we can actually use either equation and it will work. So I'm going to use this top one. So I'm going to put in my y and my x, and I'm going to see if it equals to 2 or 2 over 1. So my y is 193 minus 7. And my x is 100 minus 7. Grab your calculator. Let's do 193 minus 7 is 186. 100 minus 7 is 93. And if we actually do 186 divided by 93, that answer is 2. So is 100, 193 on this line? Yes, it is. It works. And remember, I could have used either equation. I could have done this one or this one. If you want to check this one, you can do that also. You'll still find out that the answer is 2, and then our slope is 2, so yes, it's on the line. All right, let's go ahead and let's turn to page 107. And we're doing dilations and slopes of triangles. So number 1, so here we have triangle ABC. And number 1, draw the dilation of triangle ABC with center of 0, 1 and scale factor of 2. So go ahead and try that. And so pause right now and try it. All right, let's go ahead and go over and see how you did compared to where it actually needs to be. So if we look at it, we have it, so A to B is 2 steps. And so we're doing a scale factor of 2. So we have 2, and then I need to do another set of 2. So then 1, 2. It's going to, so B prime is going to be here. C is a little bit different. So notice how I went up 1 and then over 2. Let's do that one more time because I need 2 of them. So up 1 and then over 2. And then C prime is going to be here. So this will be my new triangle. All right, go ahead and try number 2. Draw a dilation of triangle ABC with center 0, 1 and a scale factor of 2.5. Go ahead and pause and try that. Now, since you have tried it, let's go ahead and see if we can do it. So we did 2 last time. Now we're doing 2.5. So let's look at what we did before. Here we went from A to B, and it was 2 steps. And then our scale factor was 2, and we ended up going 4 steps. So what we did on number 1 is we took pretty much for A to B, we took the measurement of 2, and we multiplied by 2. And we got 4. So we're going to do the same thing with 2.5. So again, A to B is 2. So we have our 2. And we're going to multiply it by the scale factor, which is 2.5. So 2 times 2.5 is 5. So our B double prime would be to add 5. Now we need to figure out A. So let's go ahead and let's kind of look at going from like A to like this one. We're like going up a half and over 1, up a half over 1, up a half over 1, up a half over 1. And we can kind of do the same thing, up a half and then over 1. So our C double prime would end up at this point, and then we kind of have this extension part. So on number 3, it says, where is C mapped by the dilation with center 0, 1 and scale factor of S? So we're looking at that S kind of thing. So let's, first of all, we're going to look at where C is. And then we're going to look at C prime, and then S, and then C double prime. So C is at 2, 2. And then how did we get to C prime? So C prime was 4, 3. So if we kind of look at it, my X value is I can take my scale factor. So to go from C to C prime, I took my point, and I multiplied it by my scale factor. That was the X part. So I can actually write it down as 2 times my scale factor. Now let's look at the Y value. Well, the Y value, I started out as 2, 2. Then I went, C prime was 3. And then C double prime ended up being 3.5. So if we took it, and C double prime, the scale factor was 2.5, right? So if we go just from C to C prime, I took my scale factor, and I ended up, so that's S, adding 1 to it. So here we have it as far as a mapping is doing the X value was 2 times S, and then the Y value was S plus 1. So this is a way of doing the scale, doing the scale factors with it. So if we look at number 4, for which scale factor does the dilation with the center 0, 1 send C to 9, 5.5? So let's go ahead and let's write that down. So we are eventually going to end up with 9, 5.5. Right? And we actually started at 2, 2. So what we need to do is we're going to take that 2, 2, we're going to multiply it by some type of scale factor to make it the 9 and the 5.5. So remember that we actually found out the X value is 2 times the scale factor. So that means we're going to take 2, and we are going to multiply it by some type of scale factor to make it the 9. So we have it as, let's go ahead and write that down. We're going to do 2 times a scale factor equals 9. So if we do that, we can divide by 2. So then our scale factor can be 9 over 2 or 4.5. So that's the X value kind of stuff. And we also found that scale factor itself. But let's go ahead and let's try it with the Y stuff. Remember that our scale factor, the Y stuff was the scale factor plus 1. So what is 4.5 plus 1? Well, that's 5.5. Did that also make the 5.5 here? Yeah. So our scale factor that makes the 9, 5.5 work will be the 9 over 2 or 4.5. So in this lesson, again, we're just kind of looking at slopes and slope triangles and finding them on lines. This is actually from lesson 10, kind of remember what we're looking at. And that's what we're just kind of playing at. We're looking at how can we find a slope to find different points that are on the lines itself. So again, we can go ahead, we can find a slope using a slope triangle. So remember, we can draw a triangle, and we can find our vertical, which is 2, horizontal, which is 4. And remember, we can find that to either here, we can count them, or we can do 4 minus 2, which equals the 2. And then we can also use the 6 minus 2, which equals that 4. So these are a way of finding the slope, or how's that line, how is it changing? It's that slope is that vertical, and it's really that vertical distance over that horizontal distance. All right, let's go ahead and let's turn back to page 124. And let's read our I can statement. I can find an equation for a line and use that to decide which points are on that line. And so that's what we did today. We found equations, and then we found if points are on that line. So go ahead and remind yourself to go ahead and write a sentence about how you feel about today's lesson. And then give yourself a number, numbers 1 through 4. So 1, I don't really get it. 2, I kind of get it. 3, I did get it. And then 4, I can teach it to my friend. Remember that there are practice problems that go along with this lesson in Canvas. And I hope you have a good day. Thanks. Bye.